for some more kitchen table astronomy with Hampshire College astronomer Dr. Salman Hameed. Mr. Universe, you're not in China. We talked about that last week. That's a lot of drama. Go back to that, listen to that podcast, and hopefully you'll get there shortly. But today, two big things. One, at the end of this, you're going to tell us where we can see, maybe, a comet in our own skies later this week.
Right. Well, why don't I tell you in the beginning?
Because we'll want them to have to listen longer through the rest of it. It's like a teaser. It's like an old radio trick.
You see, I want people to know. They have the right to know.
Yeah, you have the right to know. But you just have to wait a little bit for it.
All right.
Nobody says you have the right to instant gratification. The other thing, and we've all been waiting for this, our entire human existence is finding any evidence of life anywhere else. And there is a mission that is leaving to perhaps the likeliest place apart from Earth in our solar system where life could exist.
Right. And so, I mean, there are many places which we get excited about regarding life elsewhere, including Mars. Very cool. Nothing against Mars. I think that would be fantastic if we find something.
It's going to be life like dead microbial life from 1 billion years ago, probably.
Well, possibly. We may find life today as well, but we don't know. But most likely, yeah, because conditions were better for life 1 billion years ago, a few billion years ago. You also have some cool places. There are moons of Saturn, like Titan or Enceladus, which can also potentially have life. Mm-hmm. But
I love enchiladas. They're so delicious.
But probably one of the best places, or the best place to look for life today, is one of Jupiter's moons, Europa. And Voyager spacecraft, when it was passing by, it took some pictures, and it was flyby, Voyager 1 and 2, and it looked like a ball, a little bit boring. There weren't many features on it, and that was interesting because normally these moons don't have atmospheres, most of the moons, and so you would expect them to be cratered, full of craters, right, like our moon is.
Yes.
And so it was actually surprising to a certain degree when you don't see any craters, or when Voyager spacecraft pictures came in and it just looked like a boring, relatively smooth ball. And so one of the suspicions was that, well, something is renewing the surface, because you still have rocks slamming into it, but you don't have any indication that, or whatever the marks have been, they are gone. So one way you can remove these marks is by water. Mm-hmm. And so there was a suspicion that perhaps there may be underwater, there's an ocean underneath the ice sheet. And then Galileo spacecraft that went there to Jupiter and its moons in the mid-90s, I think 95 it got there, and the mission was there for 7 or 8 years. It had many flybys of Europa as well. And I mean, it took spectacular pictures of Io, the other moon, or Ganymede and Callisto. But on Europa, it certainly saw crisscrossing features, crisscrossing lines in there. And it was pretty clear that there is an ice sheet, and underneath the ice sheet, there must be an ocean. And over the period of time, because it had multiple flybys, it also saw sort of like these ice sheets move. And so that was really interesting. And one of the questions would be, well, Jupiter is 5 times as far away as the Earth is from the sun. How come there is liquid water ocean over there? And that has to do with underwater volcanoes. Mm-hmm. And so on Europa, and there are underwater volcanoes partly because of Jupiter's big gravity. There's something called the tidal force, meaning to say one side of Europa that is close to Jupiter experiences higher gravity compared to the far side. So it a little bit squishes the moon, and its orbit, all of the large moons of Jupiter, the 4 big moons, Io, Europa, Ganymede, and Callisto, they have enough gravity to pull each other as well alongside with Jupiter, and so their orbits are a little bit elongated, a little bit elliptical. So you have this squishiness. So on the one hand, Jupiter is squeezing one side more than the other, and you have an elliptical orbit. So basically you are taking the whole moon or planet, however you want to think about it, whole moon, and you are squishing every side of it and softening it, and that causes the interior to heat up.
Because of friction, right? All the things moving around, it gets hotter and hotter and hotter, creates liquid hot magma or whatever, and now you got some volcanoes going on.
And if you are too close to it, like Io, for example, you just have volcanism in it. But if you're a little bit farther away, like Europa, well, on top, because there is a lot of water in the universe and in the solar system, so you do have water, but right up on top, it's frozen. But underneath, because it's the central parts that are being heated, you can actually melt ice into water. But normally, without an atmosphere, that water would evaporate. But here, the ice sheet, in some sense, is acting as an atmosphere of keeping the water in liquid form underneath it. So that's what's going on in Europa, and probably at Ganymede as well, and maybe Callisto. It gets more and more slushy or ice as you go farther out. But Europa and Ganymede certainly seems like at the right distance where there is enough heat in the middle to melt the ice, but not too much that it's just volcanism.
So everywhere on Earth that has these conditions, underwater volcanoes with liquid water, there is life. So this is one of the reasons why this is an exciting place to explore.
Yes, and in fact, on Earth, first of all, that was a surprising thing that underwater volcanoes, where it's very hot, the life is like those areas are teeming with life. But not just that, a lot of scientists think that perhaps origins of life or life may have originated in these underwater volcanoes as well. I mean, one of the key things is that for life you need water, so you have ocean. You need raw material for life, organic compounds, which are plenty available in the universe, in our solar system, but they are also brought in by comets and asteroids. But the third key ingredient is energy. And previously people used to think, and we do have the sun that provides energy. And we thought that, that is the only source of energy for life. But underwater volcanoes showed that actually you don't need the sun. You can be in the dark, right, well below in the oceans, and you can actually, these microbes or life forms can actually get energy from these underwater volcanoes. And so if there was a lot of bombardment, which we know it happened early in the solar system, then perhaps the conditions were more stable near the underwater volcanoes on Earth than on the surface. So life may have originated actually around near underwater volcanoes as well, or certainly early life thrived over there.
And then the bombardment stops, things get closer to the surface, they start changing and evolving because they're now relying on the sun instead of the heat from below.
Yeah, so, but here is the thing. On Europa, those conditions of underwater volcanoes, organic material, and water, that have existed, and that has existed also for billions of years.
So we could have underwater mermaids on Europa.
It's possible. But we have no clue what is under or what are in the oceans of Europa. I mean, it could be inert, but again, I think it would be more surprising if we have a probe that goes down and this spacecraft, or that we're going to talking about, that's not going to go in the water. But I think if in the future, 30, 40, 50 years later, we have a spacecraft that goes and explores the ocean of Europa, I think it will be far more surprising if we find that it's completely inert than that you find some form of life. And of course, what form of life, and what kind of life, and so on and so forth, those are fascinating questions. But after billions of years, with the similar conditions on Earth, where life started pretty quickly, relatively, that would be much more shocking that, hey, European oceans are inert. So it is in that context. I mean, I mentioned the Galileo spacecraft that did those observations in the mid-90s and early 2000s, that there's a new mission that's going.
And it's the Europa Clipper mission. Whose mission is it? Who's involved? And what's the mission going to entail?
So this is a NASA mission. And this is the largest spacecraft that is going to explore the solar system. So it's about 13,000 pounds. So it's big. It has huge solar panels, I think the size of a football field or something like that, or a little bit smaller than that. But or a basketball court, let's put it this way. Yeah, that's smaller than that. I was thinking, which sport am I looking at?
Cricket.
Yeah. But that would be a googly if we say it. No. But because you need, if you're far away from the sun, you actually, in order to power it, you actually need bigger solar panels. But it's being launched right now. It's scheduled for October 10th at 12:30. But it looks like it may, the weather, of course, it's dependent upon the weather. So I don't know if it's going to be launched on that date or not. But SpaceX, Falcon Heavy, that is going to take this spacecraft up. It's going to.
We'll give you a pass this time, Elon Musk.
Right. No. Look. Sometimes there are good things that people do. That is not an issue. The question is about the bad things that people do. Good things. People should be doing good things. So this is actually a positive thing, and the spacecraft is going to go first around Mars, take some gravity assist, speed up from Mars, then it's actually going to come back to the Earth.
Wow.
Get a speed up from here, and then actually go on its way to Jupiter.
That's awesome how they slingshot these craft around the different planets using the orbits to get them faster so that they don't have to use so much actual energy to propel it out there, right?
And again, for people who say, science, it keeps on changing. What do they know? They say one thing or another. So with all of these very precise accelerations, for example, using the gravity of Mars, using the gravity of Earth, it's going to get to Jupiter in April of 2030.
2030? You were complaining about people having to wait till the end of this segment to find out where the comet is, and we have to wait till 2030 for it to get there?
Yes, but I was mentioning the cool part, that we can actually exactly tell you when it's going to be there, and it's going to have sort of like its thrusters fire, because it has to slow down and be caught by the gravity of Jupiter and then to Europa. So it's going to be sort of like for 6 hours it's going to have these thrusters. But I just find it so amazing that you launch a spacecraft in 2024 and you sling it past these couple of planets, and then you go it's going to get there in April at a particular date and time. And that tells us about how well we know about gravity, how these things work, and of course, mathematics.
Mm-hmm. Speaking with Hampshire College's astronomer, Dr. Salman Hameed, Mr. Universe, also from Kainaat Studios, teaching science communication across the globe. What will this Europa Clipper mission do? You said it's not going to go into the oceans where it's likely to find life. What will it be gathering, and what will it tell us? Like an eternity from now.
Right. Well, so it has 9 instruments in there. One of the things that I think I mentioned, that there is an ice sheet on Europa, and underneath it is this particular ocean. How thick is that ice sheet? Galileo spacecraft actually could not exactly give us information whether it's a mile, 10 miles deep, 100 miles?
Great for ice skating, one way or the other.
How deep is that ice sheet? Because then that can also determine, potentially, if you are going to send a spacecraft to drill down, for example. Well, if it's a 100-mile thick ice sheet, well, good luck with that. But on the other hand, if it's thinner, then... So we don't know. So one of the things that spacecraft is doing, that it's going to measure magnetic field around it, and that will actually help us determine where exactly the ocean meets the ice sheet. And that can give us in terms of sort of like how deep or how thick this ice sheet is. But of course, it also has a high resolution camera. And in fact, it is planning on mapping almost the entire surface of Europa to resolution that is at least 5 times better than what Galileo mapped. And Galileo images are amazing. And so this one, it's going to be 5 times better resolution. And of course, it is also looking at mapping sort of like the environment around Europa as well, the interaction between Europa and Jupiter. So one of the things that I mentioned, that it has this squishiness that happens of how Jupiter's tidal forces push and pull the moon. Well, it can actually measure it precisely how it is happening and how much of this squishing takes place. All of that stuff is there. But I should mention one thing, or one of the more exciting things that we don't want to, or as scientists don't want to like really bring it up right now, but that is the cool part. And that is, it's not going to go in the ocean, but we may still be able to sample the ocean. And it's unclear whether it will be successful or not. But the idea is that there are plumes of water that comes from underneath. Now, such plumes we have seen in Enceladus, the moon of Saturn. So those are like, and Cassini spacecraft that was orbiting Saturn and that a few years ago, it actually went through those plumes, but it was not designed to potentially look for signatures of microbial life. On Europa, there are signatures that there are plumes, but then those plumes also disappear. So it's unclear how long those plumes last, or whether those plumes, how much permanent those features are. But if there are plumes, this spacecraft, Europa Clipper mission, is going to go through them and can analyze the material in it. So that is a way of sampling some of the material from the ocean. Now, you still have the question, where is the material on the plume rising? Because it could be more close to, within the ice sheet, you can have pockets of fresh water that is in there, or it could be coming down from way down the ocean, which is actually saltwater ocean and things like that. So is it sort of like more lake material, sort of like melting ice material from the top, or whether it's coming from below? We don't know.
But you can drive the spacecraft through it, do a sample, and maybe that sample will return that there's microbial life in the sample of the plume.
This is not something people are going to highlight right now, but if it happens, again, you have to be very careful, because this is a huge thing. And so we have going to find amazing things about that, but certainly if this happens, this would be hitting the jackpot. And all of this is happening while it's really risky. So one of the things that, in fact, scientists have been concerned about is the high radiation field of Jupiter. Because Jupiter has magnetic fields, a pretty big magnetic field. Europa is close to Jupiter. And so for this spacecraft, one of their biggest concerns has been and will be is that if its instruments keep on working while it goes through this high magnetic field environment, because you have these charged particles basically trapped in these magnetic fields, and the spacecraft is going through. So the spacecraft, in fact, a few months ago, there was a scare because they thought that the instruments on Europa Clipper mission may not be able to survive the radiation environment of Jupiter. They recently realized that, and so the two choices was, well, should they redo the whole thing and delay the mission for a couple of years, or they can think about a different way of orbit around Jupiter to preserve it. And so right now, what they think that the orbit around Europa, it's going to be a pretty long elliptical orbit where it takes about 3 weeks. It spends most of its time away from Europa. Then it dives down, comes close to it. In fact, it comes down to about like 15 miles above the surface, way closer than Galileo did, and then swings back and go back. And again, after 3 weeks, it comes back down. The example they were using was like, that it's like when it comes close to Europa, it would be like as if taking 1 million chest x-rays. Mm-hmm. And so that's how much I think, and that's the reason why they cover these instruments in a vault, sort of like a radiation vault that protects it. And that also has the poem, which we actually talked to poet laureate Ada Limon about her poem In Praise of Mystery, a poem for Europa. So on that vault, on one side, you have this poem in handwriting.
In her handwriting,
In
right?
her handwriting, you also have Drake equation written over there. You also have sort of like the names. It's in a microchip. About over 2 million people send names in there, and they've been miniaturized. But also the word water in waveforms in 103 languages of the earth. And so those are all things are part of that. And again, of course, those things are related to, not that it's for some aliens the way Voyager spacecraft is intended to, but all of these things, including the Voyager, but also these, in some sense, memorials or whatever you want to call that for the Earth, those are for us of how we think what is important about this mission.
Hampshire College astronomer Dr. Salman Hameed, we promised that you'd tell us about the potential to see a comet with our naked eyes in our very own skies later this week. Do tell.
I will, but I want to take 1 more minute actually to go back to the Europa Clipper mission, because I just want to mention it's always about NASA, but I want to give due credit to European Space Agency as well, because they also have a mission going to the same planet. And we talked a while back, about a year and a half ago, they have a JUICE mission, which is Jupiter Icy Moon Explorer, and that particular mission is going to get to Jupiter in 2031.
Just 1 year later.
Yeah, even though it launched early, they may be using electric vehicle or something like that. No, and so it's going to get there in July of 2031. But that is going to explore Ganymede, which also has an ocean, and 2 flybys of Europa and Callisto as well. So you will have 2 spacecrafts, hopefully both working at the same time around Jupiter, exploring Europa and Ganymede. So I think in the next 10 years or so, we will have some amazing information about these ocean worlds over there. So all of that is sort of phenomenal. So keep an eye on that as well. But you wanted to know about a comet, and here is the connection, because on radio it's all about connections.
Yes.
Because we think that oceans on the Earth, for example, may have been brought by comets and asteroids, but comets certainly, because those are big dirty ice balls, and they have crashed in the early solar system, and that may have been the source for Earth's oceans. And here you have a chance, potentially, to see a comet with the naked eye, perhaps starting from October 12th. For a few days. This is a comet A3, or comet Shickinson Atlas. But let's call it comet A3. That would be easier, because I may be mispronouncing it.
I prefer comet A24. They just make so many good movies.
This is comet A3, and it went past the sun actually just on September 27th. So not that far back, and that was its closest approach. And now its closest approach to the Earth will be on October 12th. It will be, we don't have to worry about it, because it will still be 44 million miles from us, but it should be visible post-sunset. So that's actually a good thing, because previously it was visible pre-dawn.
And then you can't see it because it's so bright out.
Yeah, not like
you gotta get up early.
You have to get up early. Yeah, it's the lazy part that's much more important. But it will be visible to the west. Planet Venus is visible as well to the west, and this will be a little bit above Venus. We don't know. Comets are finicky. They have their own mind. We don't know how bright it's going to get. It looks like it's possible that it could become a naked eye comet. Right now, people can see it well with a binocular, and I've also seen people taking pictures with iPhone. So just like we had the Aurora Borealis, where with the naked eye you couldn't see that much, but with the iPhone it could, sensitivity was more, and so you saw it wonderfully. In the same way, people are taking pictures of the comet, and that actually really delivers. So look to the western skies, a little above Venus.
Saturday night, right?
And for the next few days, it's going to go up a little. Probably it's going to be nice and bright from the 12th through the 20th. But again, here is a cool thing. I mean, this particular comet is actually coming from way out of the solar system. So, for example, Halley's Comet, well, that actually is relatively close to to us. I mean, it has a 76-year orbit, and it comes from close to Neptune, a little beyond that. This particular comet is actually coming from the Oort cloud, which is the farthest farthest part of our solar system, perhaps about a light year away, where this comet is plunging. So we know this probably is its first plunge, and it may never come back again. And so, see it with joy and see it with sadness, because this is its only ride in or only dive into our solar system. It's actually pretty close to, its speed is pretty close to the escape velocity of our solar system. So who knows? It may be free after that, and it may go and escape our solar system. So when you see this comet, just know that it has been traveling for probably tens of thousands of years from the outer parts of the solar system to get here. And now it has just gotten past to the sun, and it's moving away and going away, and you may be able to see its beautiful tail. This comet has a long tail. You should be able to see, especially with a binocular, but hopefully with naked eye as well.
Saturday night it starts, right after sunset, western sky near Jupiter.